Coding with Sonali. So today in this session we will be understanding the operation of the array, and that is the deletion operation, wherein we will be seeing how to delete an element in the array at different positions at the beginning as well as at the end, depending upon the requirement. So in the earlier session we have seen how to insert the element at different positions, even at the beginning, even at the end, and we have also seen the time complexity for the sorted as well as unsorted array. So now let's see the deletion operation. So here what we will be doing in the similar way in that is in case of the insertion we have seen. First we will do the runtime initialization of the 1D array. So we will declare the array here, the size of the array, and we know that the size of the array is fixed. So in main actually we will declare the array, say here using in this manner. So this max we will be defining, and we will ask the user to enter the number of elements user want to utilize in that array. We should keep in mind that whatever the user give the input, that is the user give the size, that size should not exceed the capacity of the array, because we know, we have already seen that array does not, in compiler does not perform array bounding check. So we are supposed to do that check in our program. We have to see that whatever number of elements the user enters should not exceed the capacity of the array, because runtime when we will access we will get a error. So that is the reason we have to handle that scenario in our program. So the same thing which we have seen in case of the insertion operation in the previous video. So here what we will do, we will simply ask the user to simply display the message, enter number of elements, we will ask the user, and we will use the scanf. We will ask the user to enter the input for number of the elements. So here we will declare the variable, that is size actually, and also I'll write this pause for the position. We'll see where to use this pause, but for the size we'll ask user to enter the size. So user will enter the size, we'll collect it at the address of this variable. This variable we have already declared. So if the size it is greater than this capacity, that is max, I will just simply display the message so that yes, so the simple message, and if this is not satisfied, well and good, that means the number of elements user have entered is not exceeding the size, then we will ask the user one by one to enter the elements as printf. One by one we will simply use the scanf function. One by one we will fill the elements. Array we have taken as arr, so array of I. Suppose this is the array after completion of execution of all these lines of instructions. So we got finally the array filled in this manner. We have initialized runtime and we got like this. Know that in case of the array indexing starts from 0 to n-1. So the position what we will consider, at index 0 we will consider position as 1, at index 1 we will consider position to be 2. So position we will consider index plus 1. Now we will consider the use case in which we will ask the user to enter the position. So first of all we should always check actually if the user enter the position as user 0. So first of all we know that our position is starting from 1 till n. Till that value if the user enter, well and good, that is okay. But if the user is entering 0 actually position, so we should give that message actually to the user that it is an invalid position. And even if the user give the position actually, so we know if the position starts from 1, it will be, here the position will be what? Position will be 7 and index will be 6. So if the position is 7, then in that case it's okay, no problem. But if the position is 8 actually, so we don't have any element which is present at position 8, so that is also invalid. So we will write the condition if position is lesser than 1 and the position if it is greater than the size. That check we will do actually. If it is invalid position, we cannot perform the deletion operations. Now let us see the logic for deletion of an element at different positions. So this is our array, that is arr. Okay, so user give the element which to be deleted, that is if the user enter the position as 3, user give this input, that is position 3. So first of all, for deletion of an element, user is supposed to only give the position. So suppose the user give this position, that is at position 3, the user have to delete the element. So the index it will be 1 lesser than that of the position, so it is 2. So user want to delete first of all this 3. What we are supposed to do, we will simply shift this, 4 here at this position, because if we'll delete this 3 actually, then nothing will be there. So this will be there will be a space here. So therefore we will shift this 4 here, right? Then we will shift when 4 comes here, that we are maintaining 4 here at this position, then we will shift this 1 here, then we will shift 7 here, and we will shift 9 here, right? So we have to shift whenever we are deleting any element. You can understand that we have to shift all the elements by one position, but this time onto the left side, not onto the right side. We have seen whenever we are inserting any element, in that case we have seen we was supposed to shift all the elements onto the right side by one position, and we started from shifting these elements from end to the position because we didn't wanted to lose the data. If you see here, if I will shift this, if I want to delete this 3 actually, then in that case I will shift 4 to here. So whether I will lose any data, we will see here. We'll see, first of all, we know that we are supposed to shift the elements onto the left side by one position. Now we have to ensure whether we have to start from the position to end or end to position. We have to see that. So let's consider if we are starting from position to end. In that case, whether we lose any data, let's check. So therefore, if we have to delete the element at position 3, therefore when we shift 4 here at this place, so you can see here we are not we have to first of all delete this element 3. Even if we shift this 4 at this position, that is well and good. We want to replace this 3 by 4, so we will not lose any data. So therefore in that case, what will happen, this 3, it will be replaced by this 4, right? So whenever again this 1, then we will shift this 1 actually to the left side here in this manner. In that case, what will happen when we'll shift, so this will be replaced by this 1 like this. Again actually this 7, when we will shift here actually, in that case we will be replacing this 1 by this 7, right? Again actually when we shift this 9 here, in that case we will be replacing this 7 by this 9. So finally we got all the elements shifted onto the left side by one position, and we have not lose any data, right? Every data is present. You can see here there was 4, 1, 7, 9. We wanted to delete 3, so 4, 1, 7, 9, we got all the elements as it is. So therefore you can understand here, we will first of all for deleting any element at the position which the user give, we have to shift the element by one position, but this time onto the left side. And one different thing also, that we have to start from position to the end actually, not from the end to position, as in we have seen in case of the insertion. So I hope so you got all this logic what we are supposed to do. And one more thing, that so what loop we should run here actually. So in that case, for int loop should be starting from the position. So first of all, what will be the index will be 1 lesser than that of position. So therefore I will be equal to pos minus 1, so here till end. So first of all, when you have seen that when we shift these elements, so we'll shift this 4 here, then 1 will be shifted here, 7 will be shifted here, 9 will be shifted here. So just in that case we will be simply writing size minus 1. So what is size here? 7 minus 1, that is 6. I want actually this this operation to happen till I index is equal to 5. I will explain you why. And I plus plus. So therefore, first of all, you understood from position to end, we want these operations to shift all the elements by one position onto the left side. Now, what we are supposed to write here, the logic, how this will work. So first of all, we know that when we are at position 3, that is index 2. So therefore, 3 minus 1, index is 2, right? So therefore, here you can see at index 2, actually it is A of I here. So this A of I actually, we want this actually, it should have the value of this element, that is A of I plus 1. Or what will be the logic in that case? A of 1. And I is equals minus 1, that is simply 2. When I is equal to 2, in that case simply A of 2 is equal to A of 3. That means A of 2 will be equal to A of 3 is what actually? It is simply A of 3 is 4. So at a of 2 we will get actually this 4. Then again this I gets incremented, this condition is checked, right? So what is the size? It is 7. So therefore I is lesser than, condition we have written that I is lesser than 6, this condition. So the condition is satisfied. I becomes when I becomes 3 in the next iteration, like this, become equal to 1. So here a of 3 you will get as 1, which is indicated by green color, you can see here. So now when again I gets incremented, this condition is satisfied, yes, so it is satisfying, therefore it enters this loop. Again a of 4 becomes equal to 7. So this it becomes equal to 7 again, and this a of 5 is equal to a of 6. So a subscript 5 is equal to a 6. A of 5 we got actually is 9. So now no elements are there wherein we want all the elements are shifted. So that is the reason when this I gets incremented to 6, we have written that it should not go, the control should not go inside the loop, because we are done with all the shifts. So therefore we have given this condition. So I hope so you understood this condition, why we are giving this. So this change is required for deletion operation as compared to that of the insertion operation. So this is the logic for that. Now let us write a code in C language, and let us ask the user to give the position and check for invalid position, and let us dump the same code there itself. So then you will understand, then you can run the same piece of code in your IDE and you can execute it. So you write the code by yourself. That means you will, first of all you can grasp the logic what is required. We have seen that, but the coding part you can do yourself. You just first try yourself what should be the condition, and then you just tally with the same piece of code. If it's not happening, then you can simply check the code and you can try the same way. So you have to do the paperwork for that, because just writing the code and executing it will also not help. So if any doubt, you just drop a comment in the comment box. I will be happy to reply over it. And if you want different example also, so that I'll explain you, I'll make a different video for the same. So anything other thing required also, you can also let me know. Or if you are having any problem in any use case, actually you can also post that in the comment. I will try my best to help you and to answer it. So now let us write the code for the same, for deletion, using this, dumping the same piece of code. We are asking the user to enter the position. Take the input from the user by calling the scanf function. After accepting this position, then this if and else condition. Why if and else condition? Because as I told, we will check for if the position is not valid. For that we will be checking. If it is not valid, then we cannot do the operation of the deletion. So therefore we will check that. So if the position is less than 1 or the position is greater than please size, so we message actually, that is printf invalid position. If this is not satisfied, well and good, that means the position is valid, and then the control goes into the else loop, else block actually. And here we are doing the same piece of code which I have shown you for this, the logic which I have shown. I have done the same piece of code here, that is the same thing. And then after this all the elements now we got shifted actually. Now what last thing we are supposed to do? We are supposed to add this thing actually, that is size minus minus. Why? Because now you can see that since we have deleted the element, all the elements we have replaced, we have shifted to the left by 1 position, therefore we have deleted. So this 3 actually is replaced by this 4, then 1 element is reduced actually, that is at this index we got this 9 shifted here. So therefore you can see nothing is here now. So therefore size minus minus. So this program, this logic we have seen for different positions. Let us see about the time complexity in this case. And if the position is 3, that is at that case, so how many shifts we are required to do? In this case, the time complexity, that is O n minus pause, that is depending upon the position. So position is 3. So if the position is equal to 4, suppose at this position we have to delete the element. So how many shifts we are required to do? So we are simply we have to shift this element here, shift this element here, and therefore how much time it will take? Actually that is, you can see here it takes more time if we have to delete the element 3 as compared to deletion of the element at 4. At 4 it takes one less shift actually as compared to that of the element which is present at position 3. So what about the use case actually if the user want to delete the very first element of the array? In case we will not ask the user to give the position, because we know that the very first element, first of all, it will be having the index as 0 and that first element is having the position 1. Therefore, what changes are required? Instead of this position, that is 3, the user is asking to delete the very first element. User want to delete this element, that is 5. So now what we are doing, we have to for deleting this 5, we have to shift 2 to here actually at this position. Then we have to shift 3 onto the left side at this place. Then 4 will be shifted here, 1 will be shifted here, 7 will be shifted here, 9 which was there earlier, and that will be shifted here, right? So we, instead of starting from the from this position till end, since we have to delete the very first element, we will start the iteration from this position till the same, but this will be changing, that is I will be changing, because we know that the very first element is having the position 1 and index 0. So therefore what will be the index actually here actually of the first element, since the array starts from 0 to n minus 1, the first element is present at the index 0. So directly we can simply give here I is equal to 0 like this. This will be the change. These operation of shifting should happen till when? The same thing actually, that is I less than size minus 1. We have to shift all the elements to the left side by one position. So therefore this will be the same, I less than size minus 1, I plus plus. So this is the change here. Just this we have to change if we have to delete the first element, and this will be also same, because we want that is A of I should be equal to A of I plus 1, like that, right? So this will be also same, and this size minus minus last after completing this for loop, then size minus minus, because after deleting the element the size will be reduced by 1. So this is at the beginning, deletion at beginning, this piece of code, right? Now we have seen for different position, we have seen at the beginning what will be the change. Now what about if we have to delete, if the user want to delete the last element? So again we will not ask the user to give the position, because we know that the last element, we know the position, it will be equal to simply the size, because this position starts from 1 to size, that is 1 to n. User actually it wants to delete actually this element, that is 9. So therefore just that is this one, the user have to delete actually this element. So no shifts are required. We want all the elements to be as it is, and just last element we have to delete. So that is very simple actually, and it will not take time also, because no shifts are there. So therefore what logic will be there if we have to delete at the end? The simply we will be decrementing the size by 1. So size minus minus at that case. So we will not write this piece of code. In that case, this piece of code we will not write. We don't want any shifts to happen. We will simply decrement the size by 1, and in that manner we will be ensuring yes the element is deleted. So you can see here how much time this is taking for deletion at the end. Only one line of instruction is required. You don't need to run the for loop, you don't require the shifts like that. So this piece of for loop is not required at all. So the time complexity will be simply order of 1. It's very much time efficient if the deletion is at the end. What about the time complexity when the deletion is at beginning? We have for deleting this 5 element, all the elements we are supposed to shift actually by 1 onto the left side. So it will take it is a very worst case actually, because we have to shift all the elements. So therefore for deletion at the beginning, the time complexity is O of n. When it was different position at between, and we have seen in that case the time complexity we have seen for different position O n minus pos. Considering the different thing about the sorted and unsorted array. So this you can see this is an unsorted array for bringing the good time efficiency. So in order to reduce the time, what different code you can do if it is an unsorted array? We know that in case of the unsorted array the ordering does not matters. So how you can improve your code, how you can reduce the time in these deletion operation if it is unsorted array? So as we have seen actually that when we have to delete at position 3, that is this element, here we was required to shift all the elements by one position to the left side. So shifting was required. So instead of shifting, replace this element which is at position 3 actually by the last element actually, that is this 9. Unsorted actually as 3. You have to therefore A of pos minus 1, because we know that index values lesser than 1 lesser than that of position. So therefore A pos minus 1 is equal to, you can simply give the last element which is there, therefore size minus 1. Size is what? 7. So size 7 minus 1, A of 6. A of 2 is equal to A of 6. Right? So A of 2 is what actually? It is simply 3. So this 3 will be replaced by this 9. So now what? 7. So 5, 2, and then this 3 will be replaced by 9. Then 4, 1, 7. So these elements you will be having in this manner. So you have replaced actually this 3 by the last element. And simply you will then do, then the next thing you will do size minus minus. That is, here you will do size minus minus. So this 2 lines of code is required actually if it is an unsorted array and if you are asked to delete the element at the given position. First of all, what will be the time complexity here? It will be O of 1, order of 1, because here we have not done any shifts and therefore it will not take time. We have done only the swapping. But in the case if it is a sorted array, in sorted array you cannot do the swapping because the ordering matters. In case of sorted array, you have to not disturb the elements which are already there, that is the ordering of that, because in sorted array all the elements are ordered depending upon the value. So you cannot do the swapping, because if you do the swapping the ordering will be changing. So that case you have to go in your loop actually, you have to shift the elements one by one to the left side. So for the unsorted array, if you are asked to delete the element at the beginning actually, in that case you will do the same thing actually, that is you will not do the shifts. Instead of shifting all the elements to the left side, you will simply swap this very first element actually by the, that is present at index 0, by the last element at beginning. So this is unsorted array. So you will simply write A of 0 is equal to A of size minus 1. That is, instead of pos minus 1 it will be A of 0. And then last size minus minus. So this is there. So you are not required to shift if it is an unsorted array. So I hope so you got all these scenarios for the sorted array and for unsorted array, as well as we have seen the deletion of the element at the different positions at the beginning, at the end, as well as we have also seen the time complexity. This is all about the deletion operation in your 1D array. And we are done with this operation. Now we will be seeing the next operation, how to traverse, how to search, how to update. So let's meet in the next session. And if you are having any doubt, it will be good to just drop in the comment box. If you want different use case, if you are having some problem, you want to try to solve it, or if you are having any doubts, you just drop your comment and I will give my best to reply for it. So let's meet. Till then, bye bye, take care.